approximation. So what is the equation that we're interested in here?
Sine of 30 degrees.
Or sine, just the equation is,
Oh, sine of,
yeah, y equals sine of x, okay? And what is the value that is close to 31? 30, yeah. So y equals the sine of 30 degrees. Now notice I'm putting degrees in here every time, because in a minute we're going to have to get into radians. Now, you could actually convert to radians before we started the problem. It's not as easy doing that. I could take this 31 and multiply it by pi over 180, and I'd have 31 pi over 180. That's not as easy to work with. So I'm going to do my substitution at the last minute as far as converting from degrees to radians. All right, and what do we know about the sine of 30 degrees?
that's the pi over 6.
It is equivalent to pi over 6 as far as radians is concerned.
It is a 60, 30, 60, 90 triangle.
Okay. How do we label it?
Oh, 1/2 square root, yeah.
Okay. So the sine is opposite over hypotenuse, which is 1/2, yeah. So the sine of 30 degrees is 1/2. So now what is the slope at 30? Well, what's y prime? Cosine of x. We'll start off as cosine of x. So y is the sine of x, so y prime is the cosine of x. So yes, we do want to know that slope when x is 30. So it's the cosine of 30 degrees.
Which is square root of 3 over 2.
Square root of 3 over 2. So the cosine of x is the square root of 3 over 2. So we've got our point and our slope now, right? Mm-hmm. Okay. So again, you've got y minus y sub 1 equals m times x minus x sub 1. So y minus, and what's the y value we have for, that we do know?
1/2.
1/2, so it's y minus 1/2 equals to the square root of
3 over 2.
Okay, times that's x minus x sub 1. Not 30.
X minus.
So what's, well, yeah, let's go ahead and put the x in there. X minus 30 degrees, right? Okay. So I get y minus 1/2 equals the square root of, no, let's go ahead and move that over. So y equals the square root of 3 over 2. All right, what's the x value that I'm interested in solving for?
31 degrees.
31 degrees, so it's 31 degrees
Minus 30 degrees.
minus 30 degrees
Plus 1.
plus 1/2.
So
Square root of 3 over 2 times 1 degree plus 1/2. All right, now, you don't just say square root of 3 over 2 times 1 and then add 1/2 to it. Because again, we're talking about two different number systems. So we need to convert that 1 degree into radians to get it into the base 10 number system. So
it'd be pi over 80.
So pi over
180.
180, pi over 180. Again, 1 degree is equivalent to pi over 180 degrees. So now I have y equals the square root of 3 over 2 times pi over 180 plus 1/2. Which would be pi square roots of 3 over 360 plus, and 1/2 would be 180 over 360.
Mm-hmm.
Okay. So we get pi square roots of 3 plus 180 over 360. Now, let's do that approximation in your calculator. Again, when you're doing this, and I had a student who messed up with this yesterday in class, got to make sure you put that whole numerator in parentheses, or else it'll read it incorrectly. And also, we can't say, oh, that's 1/2 and simplify out there. Remember, the only way you could simplify is if you could factor it out of both terms.
Zero point five one five one.
5151. Okay. Now, do the sine of 31 degrees in your calculator. And I would just do, I would switch to degree mode and do sine 31 like that. Five one what? 50. Okay, so this is less than our approximation, so that's on a part of a curve that's also concave down. Remember, sine curve, you're switching back and forth from concave up to concave down, so you may not know immediately which one it's going to
Wait,
be.
concave up though, right? With the,
No, at 30 degrees. Oh, you're concave down at 30 degrees. Remember, your sine curve takes on that shape right there, right? So this is pi over 2,
Oh, that's right.
so it's concave down right there. Yes.
I was switching it. I was like, wait, that's less than that. But it was because if our approximation is greater than the actual one, it's
Yes.
yeah.
Yeah, right in here we would get approximations that would be less than. So, how do y'all feel about that? Okay, so what I want y'all to do at your desk is approximate the cosine of, no, let's go with 44 degrees.